Welcome to Learn with Us. This is the 13th lecture of Basic Electronics.
First, we will have a quick review of our previous lecture. In your last lecture, you studied how diode acts as a clamper, and you also understood different types of clamper circuits with the help of examples. Now, what are the learning objectives of this lecture? In this lecture, you will study how diode acts as a clipper, and you will also understand different types of clipper circuits. Now we will understand how diode acts as a clipper. The diode clipper is also known as the diode limiter. It is a wave shaping circuit which takes an input waveform and clips or cuts off its top half, bottom half, or both halves together. In general, clippers are classified into two types: series clipper circuits and parallel or shunt clipper circuits. Clipper circuits are further classified on the basis of positive clipper circuits and negative clipper circuits. Positive clipper circuits remove or limit the positive half cycle of the input signal, while negative clipper circuits remove or limit the negative half cycle of the input signal. In biased clipper circuits, the level to which an AC voltage is limited can be adjusted by adding a DC battery in the clipper circuits. So we can say that the series clipper circuits can be further classified into series positive clipper circuits, series negative clipper circuits, series positive clipper circuit with positive bias voltage, series positive clipper circuit with negative bias voltage, series negative clipper circuit with positive bias voltage, and series negative clipper circuit with negative bias voltage. Similarly, shunt clipper circuits can be further classified into shunt positive clipper circuits, shunt negative clipper circuits, shunt positive clipper circuit with positive bias voltage, shunt positive clipper circuit with negative bias voltage, shunt negative clipper circuit with positive bias voltage, and shunt negative clipper circuit with negative bias voltage. Now we will look at the circuit diagrams of series and shunt clipper circuits. In series clipper circuits, diode is connected in series with load resistor. So its circuit diagram is like this, and this is load resistor RL, and output voltage is measured across this load resistor. This is diode and this is input source. So this is series clipper circuit. Now in case of parallel or shunt clipper circuits, this diode is connected in parallel with this load resistor. So now circuit diagram of this parallel clipper circuit is like this, where this is load resistor RL and output voltage is measured across this load resistor. This is diode, this is another resistor R, and this is input source. So this is parallel or shunt clipper circuit. Now look at this example. If you have a circuit like this, where this is load resistor RL, and here voltage drop is V0, here voltage is VD, and here you have input source. And if your input signal is like this, where this is positive Vi, and for suppose here it is 10 volts and this is negative Vi and it is minus 10 volts. So how you are going to start your analysis? Again, you will look at that part of input signal which will make this diode forward biased. We know that when diode is connected in this direction, then it will conduct during positive half cycle of the input signal. So we start our analysis from positive half cycle of the input signal. Now, during this positive half cycle, this circuit will look like this. It means now this diode is short. Here you have Vi. Now this terminal is positive, this is negative, this is Vd. This terminal is positive, this is negative, this is positive, this is negative, and here we have V0. Okay. Now if we apply KVL here and we start from this point, so our KVL equation will be minus Vi plus Vd plus V0 is equal to 0. And if we assume that this diode is ideal, it means here this Vd is 0. Now this equation becomes minus Vi plus V0 is equal to 0. It means your output voltage is equal to Vi, and we know that here Vi is 10 volts. It means V0 is equal to 10 volts. Okay. Now what would be your output waveform here? During positive half cycle, this V0 is Vi, which means 10 volts. Okay, 10 volts, and this is V0. Now, what would happen during negative half cycle of the input signal? Now, these polarities are reversed. It means now this is negative, this is positive, and it will make this diode off. So now the circuit is open, and here you have V0. We know that when diode is off, here current is 0, and since this is series configuration, it means in this circuit entire current is 0. Okay. Now we know that according to Ohm's law, V is equal to IR. It means here V0 is equal to IDR, because here current is ID is equal to I. So V0 is equal to 0, because we know that in this case ID is 0. It means V0 is 0. So during negative half cycle of input signal, this output voltage is 0. Okay. Now for second input signal, you will get this output waveform. Okay. Now as you can see, this circuit clips the negative half cycle of the input signal. So it is an example of series negative clipper circuit. Series, why? Because here this configuration is series. Okay. Now look at this example. If the clipper circuit is like this, then how would you analyze this circuit? If you have input signal like this, where this is positive Vi and it is 10 volts and it is negative Vi, which is minus 10 volts. Again, you will look at that part of input signal where this diode is on. So this direction of diode indicates that it will be on during negative half cycle of the input signal. So we start our analysis from negative half cycle. During negative half cycle, this circuit will look like this. It means now this diode is short. Now here this terminal is negative, this is positive, this is Vi, this is negative, this is positive, this is Vd, this is positive, this is negative, this is V0. Now if we apply KVL here and we start from this point, our KVL equation will be plus Vi minus Vd plus V0 is equal to 0. And if we assume that this diode is ideal, it means here this Vd is 0. It means now this equation is V0 is equal to minus Vi, which means it is minus 10 volts. So your output waveform will be like this, where you have an output voltage of minus 10 volts during negative half cycle. Now what would happen during positive half cycle? We know that during positive half cycle this diode will be off. So now this circuit will be open, and in this case this is positive, this is negative, this is V0, and again it means here ID is 0, and it means the current in this entire circuit is also 0 because it is a series configuration. And we know that V0 is equal to IR. Here it is IDR and it is equal to 0. It means during positive half cycle this output voltage is 0 volts. Now for second input signal you will get an output waveform like this. Now as you can see in this case, this positive half cycle of input is clipped, but the circuit has allowed negative half cycle of the input signal. It means it is an example of series positive clipper circuit. Why series? Because this is a series configuration. Now look at this example. If you have a circuit like this, where this is load resistor RL, and here we have voltage drop V0 or output voltage. This is a DC battery. This is positive terminal, this is negative, and here voltage drop across this diode is Vd, and this is input voltage. Now as you can see here, this DC battery is connected. It means now this circuit is biased. Now if you have an input signal like this, where this is positive Vi input, suppose here it is 20 volts and this is negative Vi and it is minus 20 volts here. So how you are going to analyze this circuit? Again you will look at this diode, and you know that this direction of diode suggests that it will be on during this positive half cycle of input signal. But here this additional DC source is also connected, which will also affect this diode. So in this case we will find transition voltage. This transition voltage will cause a change in state for the diode. In case of ideal diodes, transition between states will occur at a point where Vd is 0 and Id is also 0. So this is the condition of transition voltage in case of ideal diodes. So if you apply this condition here, you get a circuit like this. Now we know that during positive cycle this diode will be short. So this is positive, this is negative, this is positive, this is negative, this is Vd, this is positive, this is negative, this is V, this is V naught, this is positive, this is negative. And here current will flow in this direction, but we know that in this condition Id is 0. So here current is also 0 and this Vd is also 0 here. And for suppose if this V is 5 volts, okay. Now if we apply KVL here and we start from this point, this is Vi. So our equation will be minus Vi plus V plus Vd plus V naught is equal to 0. And we know that here this Vd is 0 and from Ohm's law V is equal to IR. So here this V naught will be equal to IDR. We know that this ID is 0, it means this V naught is also 0. So here it is 0. So now your equation will be minus Vi plus V is equal to 0. It means Vi is equal to V and it is 5 volts. So Vi is 5 volts. So it is your transition voltage. It means when Vi is less than V, that is 5 volts, then your diode will be off, and when this Vi is greater than V, that is 5 volts, then your diode will be on. Okay. Now you will analyze this circuit during positive half cycle. Okay, now this diode will be on and this is your circuit, and here we have V naught, positive, negative. Here we have Vd, positive, negative. This is positive, negative, V. Now this terminal is positive, this is negative, this is Vi. So in this case, your KVL equation is minus Vi plus V plus Vd plus V naught is equal to 0. If this diode is ideal, then this Vd is 0. Now in this case, this equation will become like this. We know that Vi is 20, so this is 20. We know that V is 5, so this is 5. It means here V naught is equal to 15 volts. Okay. Now we will look at this circuit during negative half cycle of the input, and in this condition this diode will be off. So you know that here is V naught, this terminal is positive, this is negative. Here we have V, this is positive, this is negative, and now this terminal of input is negative and this is positive. And we know that when diode is off, then there is no current flowing through this diode. It means here ID is 0. So what would be our output voltage here? We know that V naught is equal to ID RL because this is RL, and here ID is 0. So it means our output voltage will be 0. Okay, now how you are going to draw your output waveform here? Now look at this. We know that this was our input signal where it is positive Vi, that is 20 volts. We know that our transition voltage is 5 volts and it is drawn like this. This is 5 volts. As I have mentioned that when Vin is less than V, diode is off. It means in this region of input signal, this diode is off because in this region, this input signal is less than 5 volts. Again, if you look at this point, then in this region of input signal, Vin is less than 5 volts. It means this is off. Okay, and we know that during positive half cycle, our output voltage was 15 volts. Okay, and when Vin is greater than V, diode is on. It means now in this part we'll have an output voltage of 15 volts which is drawn like this. Okay, now this amplitude is 15 volts. Okay, and we know that during negative half cycle V naught is 0. So this is drawn like this. Okay, now if you draw this output waveform separately, it is like this. Okay, so this amplitude is 15 volts. Okay. So as you can see here, this negative half cycle of input is clipped and this configuration is series, and here this negative terminal of battery is connected to diode. It means this is an example of series negative clipper with negative bias voltage. Okay, now look at this example. If you have a circuit like this where now this positive terminal is connected with diode, here we have load resistor RL and voltage drop across this resistor is V0, this is VD and this is V. Okay, now if you have a square wave input signal which is like this, where this is positive Vi and it is 20 volts and it is negative Vi which is minus 20 volts. Okay. The analysis of Clipper networks is easier with square wave input because here we have only two levels, as you can see here, that is two DC input levels. So in this case, output waveform is plotted in the proper time frame, unlike previous example. Okay, now we know that when diode is connected in this direction, then it will be on during positive half cycle. So during positive half cycle, this circuit will look like this. It means now this diode is short and here we have V0, this is positive, this is negative, this is V, and again for suppose here this V is 5 volts Now this terminal is positive, this is negative, this is Vi. Here we have Vd, negative, positive, positive, negative. Okay. Now if we apply KVL here and we start from this point, our equation will be minus Vi minus V plus Vd plus V naught is equal to 0. And in case of ideal diode, this Vd is 0. It means here our equation will be V naught is equal to Vi plus V. We know that here this Vi is 20 volts. It means here it is 20 and this V is 5 volts, so it is 5. It means our V naught is 25 volts during positive half cycle of input. So our output waveform will be like this, where this is output voltage which is 25 volts during positive half cycle. Now during negative half cycle, this diode will be off. So now your circuit will look like this. It means now this diode is open, and here we have Vi. Now this terminal is negative, this is positive, this is negative, this is positive. Here we have V naught, this is positive, this is negative. We know that when diode is off, then there is no current flowing through it, so ID is 0, and we know that V naught is equal to ID RL, okay, and this ID is 0, it means V naught is 0 volts. So during negative half cycle, this output voltage is 0 volts, okay. Now as you can see, this circuit is clipping negative half cycle, and this configuration is series, so it is series negative clipper with, now look at this terminal, you know that this positive terminal of battery is connected with diode. It means it is series negative clipper with positive bias voltage, okay. Now here is your class task. If you have one circuit like this, where this is V naught plus minus, here we have Vd, this is minus plus V, and this is Vi. And then you have another circuit like this, where this is plus minus V naught, this is Vd, this is plus minus V, and this is Vi, okay. Now this circuit is an example of series positive clipper with positive bias voltage, and this is an example of series positive clipper with negative bias voltage, okay. If you have a square wave input signal which is like this, where this is plus Vi and it is 20 volts, and this is minus Vi and it is minus 20 volts, and this battery here V is 5 volts, okay. Then what would be your output waveform for circuit number 1 and circuit number 2? Okay, so this is your class task. Now we will look at some examples of shunt or parallel clipper circuits. If we have a circuit like this, we know that in shunt clippers, load resistor is connected in parallel with this diode, and here voltage drop across this resistor is V0, this is RL, this is R1, and this is Vi or input source. Now, if you have an input signal like this, where this is plus Vi and it is 10 volts, and this is negative Vi and it is minus 10 volts. And here if this R1 is 10 kilo ohms and this RL is 100 kilo ohms, so how you are going to start your analysis? Again, you will look at the direction of diode, and we know that this diode will be on during positive half cycle of the input signal. So we start our analysis from positive half cycle of input. Okay, now in this case this circuit will look like this, where this diode is short and here we have a resistor. We know that this is positive, negative V0. Here we have VD. This is positive, this is negative, and now this terminal is positive, this is negative, this is Vi, and this is R1, this is RL. Okay, now just look at this loop. If we apply KVL here, and here our equation will be minus VD plus V0 is equal to 0, and if we assume that this diode is ideal, it means this VD is 0. It means here output voltage is 0 during positive half cycle of the input signal. Okay, now what would happen during negative half cycle of input? During negative half cycle, this diode will be off. So now this circuit will look like this, where we have V0 here, and here it is R1, and this is negative now, this is positive, and this is VR. Okay, now in order to find this VR, we will apply voltage divider rule here, and here the formula will be V0 is equal to RL divided by R1 plus RL, and this term is multiplied by Vn. Because we know that here is RL and we have to find V0, which is across this resistor RL. So this RL is written here. Okay. Now if we put values here, we get V0 is equal to 100 divided by 100k, 10k plus 100k, because we know that here R1 is 10k and RL is 100k, and here in this case input voltage is minus 10 volts, so you will get minus 9.09 volts. Okay, so this is the value of output voltage during negative half cycle of the input. Okay, now what would be your output waveform in this case? We know that during positive half cycle, the output voltage was 0. So it is drawn like this, and during negative half cycle, we were getting minus 9.09 volts. So this is your output voltage, which is minus 9.09 volts. Okay. Since here positive half cycle of the input signal is clipped and only negative half cycle is allowed, so it is an example of shunt positive clipper. Okay. Now look at this example. If you have a circuit like this, where we have a load resistor here, this is plus, minus, this is V0, this is R1, this is Vi. Okay, if this R1 is 10 kilo ohms and this RL is 100 kilo ohms, if your input signal looks like this, where this is plus Vi and it is 10 volts, and this is minus Vi and it is minus 10 volts. So how you are going to start your analysis? Again, you will look at the direction of diode, and we know that when diode is connected in this direction, then it will conduct during negative half cycle of this input signal. So we start our analysis from negative half cycle of this input signal. So in this case, this circuit will look like this. It means this diode is short here, and we know that here we have V0, this is plus, this is minus, this terminal of diode is negative, this is positive, this is VD, and this terminal is negative, this is positive, and this is R1, this is RL. Okay. Now if we apply KVL here in this loop, then our KVL equation will be plus VD plus V0 is equal to 0. It means V0 is equal to minus VD, and in case of ideal diode, this VD is 0. It means here this V0 is 0. Okay. Now what would happen during positive half cycle of input? During positive half cycle, this diode will be off. So now this circuit will look like this. Okay. We have V0 here, this is RL, this is positive, negative, this is R1, this is Vi, and now this terminal is positive and this is negative. Okay. Again, you will use VDR here for finding this V0, and the formula will be RL divided by R1 plus RL, and here we have Vi. Okay. Now if we put values here, we have R1 is 10 kilo ohms, RL is 100 kilo ohms, and in this case Vi is 10 volts. Okay, so after solving this, you will get 9.09 volts, which is output voltage. Okay, so what would be your output waveform here? Output waveform will look like this. We know that during positive half cycle, output voltage is 9.09 volts. So this is your output voltage, and it is 9.09 volts. Okay, and during negative half cycle, output voltage is 0. Okay, so this is your output waveform, and as you can see here, this negative half cycle is clipped and only positive half cycle of the input signal is allowed. So it is an example of shunt negative clipper. Okay, that's all for today. Now, what are the key takeaways of this lecture? In this lecture, you understood how diode acts as a clipper, and you also studied about different types of clipper circuits here, and you also solved some examples.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.